Jackpot. That's better, right? The thing that I want to point out to you is yours says x squared plus bx plus c, but I think what's very important is you understand that what we're focusing on today are quadratic equations that look like that, but the coefficient of the first term is 1. Okay, it may not be written in your handout, but in all of the ones we do today, it boils down to a coefficient of 1. If that coefficient is not 1, you do not know how to solve these equations yet. We're going to be doing that on the first day we get back. And it turns out that there's a relationship between the numbers that are solutions to that equation and the factored form of that equation. So most of this unit is about factoring. And you need to be like very proficient at factoring to be successful in the remainder of this course. There are some units where the first step in solving the math problem is to factor everything, and you might have in some of the problems in those units 8 different expressions that all need to be factored. And let me be clear here, factoring is a grade 10 skill. So what we're really doing is reviewing grade 10. And the real Math 20 math that comes after factoring those 8 things, that's something new. So you can't take 3 or 4 minutes to factor an expression. You need to be proficient, accurate, and quick at factoring expressions. Okay? So, factor this polynomial. Because we have a 1 for the coefficient of the quadratic term, the 1x squared is the quadratic term, the negative 3x is the linear term, and the negative 10 is the constant term. Because we have a coefficient of the quadratic term of 1, factoring this simply is a matter of you asking yourself this: what 2 numbers multiply to give negative 10, and those same 2 numbers have to add to give negative 3? That's what this question boils down to. And I want you to be very clear about something here. These are not the answers to any equation or anything like that. All we're doing is we're factoring. So you go through all of the factors of 10 in your head, neglecting the negative aspect. This is the way I think of it. And we really have these sets of factors, 1 and 10 and 2 and 5. Would you agree? Okay. Try to remember this in factoring. More often than not, it's numbers that are closer together than further apart. There's always going to be exceptions, but you would never try 1 and 10 first. And I think this is very basic. Most of you, I hope, everybody can see that the numbers are 2 and 5. And if the 5 is negative, that will give us the negative 3 when we add them together. So the 2 kind of mystery numbers here are negative 5 and 2. And that means this factors into x minus 5 and x plus 2. And even though this is math 10 right now, I want us to FOIL that out to understand why this works. When you FOIL this out, this is our answer. Okay, we're done. But when you FOIL this out, you go first, outer, inner, last. Your first will be x times x, which is x squared. Well, that's what we want. Your last will be negative 5 times 2, which is negative 10. That's what we want, and that's why we were looking for 2 numbers that multiplied to give that. My outer is 2x. My inner is negative 5x. Well, that adds to give me negative 3x, and that's why those 2 numbers, 2 and negative 5, had to give negative 3 when you added them. Again, I'm choosing to explain math 10 here, but it's really basic stuff. Okay? And the bottom line is you should be able to factor quadratic expressions that start with a 1 for the x squared. If they're factorable, you should be able to factor them in 5 seconds of thought. 10 max. It shouldn't be something that takes you forever. And as well, and I know that I'm putting maybe pressure on you to do things that you're not used to doing. I'll tell you what, if I say to you what 2 numbers multiply to give negative 10 and add to give negative 3, and your first impulse is to grab your calculator, I'll be honest with you, that scares me. That tells me that you're going to really struggle. You shouldn't need your calculator to answer that question. You should know your times table. You should know what numbers multiply to give 10. Okay. Anyway, that's the factored form. X minus 5, x plus 2. Any questions with that? And if you're sitting there going, well, this is so simple, why is he droning on about it? Because I know from experience for some students they're going to struggle here. The wheels are going to fall off the bus, as they say. So I want to make sure that you take this seriously. Solve this quadratic equation by doing what we did yesterday. I hope it's not lost on you that this quadratic equation, x squared minus 3x minus 10 equals 0, is the thing that we just factored set equal to 0. So how are we going to solve this using graphical methods? You're going to graph that function and you're going to find the two x-intercepts. And I'm going to give you a minute to do so. That ought to have been enough time. I'm going to graph it just to show you what we're looking at, but I'm not going to actually go through the steps of finding the x-intercepts. You know how to do that. It's y equals x squared minus 3x minus 10. Zoom 6 is probably your first line of attack. This is what the quadratic function looks like. That is the equivalent function to the equation that we're trying to solve. So the x-intercepts turned out to be positive 5 and negative 2. And that means that the solutions to this equation here are x equals 5 and negative 2. Are we in agreement there? Okay. What do we notice about these two solutions? Be very careful in answering this. When we look at how we factored this polynomial that was equal to 0, it factored into x minus 5, x plus 2. Are you with me on that? The numbers we discovered when we factored it were negative 5 and positive 2, but the solutions to the equation are 5 and negative 2. They're opposite. And it isn't that you just want to remember they're opposite. Something very important is happening here. This equation, which was x squared minus 3x minus 10 equals 0, well, let me write this out and ask you a question. Is this the same equation? Sure, because x squared minus 3x minus 10 is exactly the same as x minus 5 times x plus 2. Let me now go a little bit further and ask you this question. And I'm not trying to be funny here. Is this the same equation? Well, yeah, I've just put a little bit of room between those two factors. But I put room between them because factors, this is at the heart of so much in this course, are things that are multiplied together. If I say to you that the factors of 6 are 2 and 3, that's because 2 times 3 gives you 6. Factors are things that multiply together to give you the entire product, the entire expression. So now follow along this logic. Forget about what's on the screen right now. If I have this multiplied by that, if I have two things multiplied together, what's the only way I can get 0? If I told you that this multiplied by this has to give me 0, what's the only way that I can get 0 out of that? What has to be true about A? Go ahead.
One of the two has to be.
One of the two has to be equal to 0, right? So if I have A times B equals 0, this becomes A equals 0 or B equals 0. Yeah? Okay, well, what we have here is x minus 5 times x plus 2 equals 0. Well, that means x minus 5 equals 0 or x plus 2 equals 0. And if I solve this equation here, I get x equals 5 And if I solve this equation here, I get x equals negative 2. So there's a lot going on here. Let me boil it down to what's important now. The reason why the solutions to the equation are x equals 5 and x equals negative 2 is because they are the solutions to the factors of the equation equaling 0. And in fact, what we would do is we would say that this number is a solution, no, I wouldn't even say solution, is a 0 of x minus 5. This number is a 0 of the factor of x plus 2. And I want you to notice something. This is going to take a while for it to sink in for some people. I want you to notice something. When you look at this equation right at the top of the screen, that's a Math 20 equation, isn't it? You don't solve that in grade 10. But if you look at what we did, we turned that equation into this, which is still a Math 20 equation, but then we turned it into this and this. And quite frankly, we've turned it into grade 5 equations, or wherever students learn about negative numbers. We've gone from quadratic to 2 linear. These are both linear now. And solving a linear equation is a piece of cake. This is the whole point of factoring. You turn a quadratic equation into 2 linear equations. Once again, if I look, let's focus on just one of these things that I have written here. Let's focus on this. If I say to you, everybody, what value of x makes this 0, it should be very apparent 5 makes that 0. Yes? But 5 is being multiplied by the x plus 2. So if x minus 5, which is 0, if that factor is 0 and it's being multiplied by x plus 2, if this is 0, then the product will be 0. If I say what value of x makes this 0, well, the answer is negative 2. So when x is negative 2, that whole factor is 0 multiplied by the other factor, which quite frankly I don't care what it is at that point, because it's going to be 0. Are you catching my drift here? Okay. Well, let's solve some quadratic equations then. So how do we do this? We factor this. All of the quadratic equations we look at today will be factorable. If they are not factorable, then they need to be solved some other way. Okay? It doesn't matter. We'll learn about that later. Well, we're looking here for 2 numbers. Because this starts with a 1x squared, we're looking for 2 numbers that multiply to give negative 27. And those same 2 numbers have to add to give 6. This has to give us negative 27. This has to give us positive 6. So I always start off with the factors. How many of you, by the way, know the numbers like almost immediately upon hearing the problem? Negative 3 and 9, right? That's how quick it should be. If, as a warm-up, because it's been a while, you need to start going, okay, 27, what are numbers that multiply to give 27? 3 and 9. Oh, wait a minute. They're off by 6. If this is negative and this is positive, it will work. Don't start with 1 and 27, though. So the 2 numbers are negative 3 and positive 9, which means this factors into x minus 3, x plus 9. And here's the part that I need you to get used to doing. All that other stuff, you don't need to show that. That just probably goes on in your head. You cannot, and I do not want you at this point just putting this. I don't want that. By the way, this is wrong as well. It's an equation. It needs to be equal to 0. Okay? So this equals 0. What you need to write is this. X minus 3 equals 0. X plus 9 equals 0. Just, as I said, I mean, I don't want you to blindly put your faith in anything anybody tells you, but please trust me on this. If you don't get in the habit of doing that now, it's going to cause serious problems in your understanding of math and your ability to do math later. Okay, just believe me. So the two answers are 3 and negative 9. Take a look at the next one. Well, we factor it. The leading coefficient is 1, so we can put k and k. We're looking for two numbers that multiply to give 50 and add to give negative 15. Okay, wait. If they multiply to give positive 50, but they add to give negative, then they had both better be negative. So now you start running through the factors of 50 in your head, and the first thing that pops into my head is 5 and 10. And 5 plus 10 is 15, so negative 5 plus negative 10 is 15. Oh, that means k equals 5 and k equals 10. And, okay, sorry. That means k minus 5 equals 0, and that means k minus 10 equals 0. I need to write that down at this level. And that means you solve this equation and you get k equals 5. You solve this one, you get k equals 10. It's really pretty straightforward, I think. But it presupposes that you can factor. And I'm just being brutally honest with you here. Every time I teach this course and we get to this point, I say in the back of my head, man, everybody can factor this, but there are some people that can't. And if you can't factor, you have to learn how. You're running out of time to finally figure out how to factor. All right. X squared minus 16, x equals 80. Well, the only thing that's changed here is you need to zero this equation first. Remember, that's your overriding thing that you always do with quadratic equations. You have to zero it before you proceed. Whether you solve it by factoring or graphing or completing the square, which we will learn, or by using something called the quadratic formula, which we will learn, you have to zero the equation first. Two numbers that multiply to give 80 and add to give negative 16, well, negative 80. Well, you might want to grab your calculator here. I do this on paper. I say, well, 8 times 10 gives us 80. I can't get 16 out of that, can I? But what I could do, and I hope this makes sense to you, is if I want to know some other factors of 80, I could take this number and double it, and this number and cut it in half. It should still multiply to give 80, but this is not going to give me 16. If I take this number 8 and divide by 2 and multiply this by 2, these numbers multiply to give 80. Oh, and they're 16 apart. So the two numbers will be 4 and 20, and I just have to look at this and say, well, which one's going to be negative? I want to get negative 16x out of the deal, so the 20 has to be the negative one. That means x plus 4 equals 0. Excuse me. And x minus 20 equals 0. You don't need the brackets there. I'm not sure why I put them. So you solve this and get x equals negative 4. You solve this and get x equals 20. Pretty straightforward. D, well, right now there is not a 1 in front of the p squared. And the biggest mistake that I see people make, I had some students write an exam yesterday in Math 30-1, and there were 2 students who made this mistake. Don't write this down. They had something like this. It involved trigonometry as well, but they had something like this. And they tried to, this is equal to 0. They tried to factor this. don't ever, ever try to factor a quadratic if the first term is negative. In other words, you zero the equation by moving everything to the side of the equation that gives you positive quadratic terms. So we're going to move the p squareds to the right, where it's going to join the 6p, which was already on the right, and then we have to subtract 27 as well. And now, geez, didn't we do this one already? I think we did. I mean, I don't know if it was p, it might have been x or something else, but it was 9 and negative 3. You do not need to show how you get p plus 9 and p minus 3. That's just going on in your head. That means p plus 9 equals 0 and p minus 3 equals 0, which means p is equal to negative 9 and p is equal to positive 3. That's it. Okay, well, these are quadratic, definitely. They're a little bit more complicated. We're going to zero the equation first and get 7x squared minus 56x plus 49. Just let that percolate, equals 0. Let that percolate in your brain and make sure you understand how I'm getting that equation. I told you we were only going to be looking at what we do if the coefficient of the first term is 1. The coefficient of the first term here is 7, so what do we do? Go home? What's that page? Right, you factor 7 out. If any of you were thinking you divide everything by 7, I would like you not to think that way. We're going to factor a 7 out, because all of these terms are divisible by 7. I think 8 times 7 is 56, pretty sure. And then plus 7 equals 0. I don't want you to divide that 7 out. I want you always to leave the factor there. Okay? It would not be wrong if you divided both sides by 7 here, but it leads to some problems later. So now we ask ourselves, do I have a pair of numbers that multiply to give 7 and add to give negative 8? Well, they both have to be negative. 1 and 7 do the trick. So now I can say x minus 1 equals 0, x minus 7 equals 0, x equals 1, x equals 7. Same thing here. If you can't factor 8 out because it doesn't divide without remainder into the other terms, then you don't know how to factor, you don't know how to solve that equation yet. But 8 does. We can factor out an 8 and have 8 multiplied by t squared minus 7t plus, I want to say 14. It's not 7, it's 9, isn't it? Minus 9t plus 14. Question? We're okay? You sure? What's going to happen, were you going to ask, shouldn't they be opposite or something?
No, I'm just looking at the line 7x minus 1, 7, or x minus 7. I don't know what my brain did for
I don't know if this is what you are getting at, Liberty. You're looking at this line, right? And again, I don't know if this is what you're getting at, but I'm going to explain something anyway, even if it's not. What we've done is we've made two equations out of that by saying anytime one of the factors is equal to 0, the whole thing will be equal to 0. I feel as though I didn't do a stellar job explaining that earlier, so let me repeat it. The reason why I set this equal to 0 is because this is a factor. And if that factor is equal to 0, since it's being multiplied by everything else, you'd get 0, which is what we want. It says equals 0. And then we set up 1 as well for the x minus 7. And again, I don't know if this is what was troubling you, but even if it wasn't, I think it's worthy to note. We don't worry about this as a factor. It is a factor because it doesn't have x in it. There's no value of x that will make the number 7 0. I don't think that's what you were getting at, though, was it? But do you think you're okay? Okay. All right, let's keep going here. What two numbers multiply to give 14 and add to give negative 9? Well, there's only a certain number of options we have here for the 14. It's either 14 and 1 or 2 and 7. T minus 2, t minus 7 does the trick. Don't forget equals 0, and I should be writing equals 0 everywhere. That means that t minus 2 equals 0, t minus 7 equals 0. So t is equal to 2, and t is equal to 7. Now, again, I think it's very simple, almost childlike in terms of the skill level involved and the math involved. But I've tried to show you exactly what you need to do step by step, because as things get more complicated, just looking at it won't do the trick. Okay? Just please trust me on that. I want you to be successful. So on page 4 of the handout, there's a whole bunch of quadratic equations. And really, other than this extra step 3 and 4, this is just a test of your Math 10 skills. Can you factor, right? But these are the steps that I want you to include. I want to see in your work, which means you don't have enough room on that handout to do it. Okay? I want to see step 1 is the question, right? I want to see the factored form of the equation equals 0. I want to see each of the two factors equal to 0, and then you can write your answers. There's an additional step here for some of these because you have to factor out the common factor. What am I assigning? I'm assigning for the next half hour you work through as many of these as possible. And for some of you, you're going to be able to do them all. I'm going to be walking around the room starting in about 5-10 minutes just to see your progress, to find out where we're at in terms of factoring. Because in my mind, each of these shouldn't take you more than about a minute. Like even less, if you've mastered it. So get to work on that, please. I need to check to see, I have somebody else writing an exam after school from yesterday's exam, and I need to check to see if I have a different exam to give them, and if I do, then I will hand back your exams so you can take a quick look at them. Of course.